Hello guys, welcome to the day 4, a live session of Langchain. Just wait for a couple of minutes and then we will start. Okay. Can anyone ping in chat section? My screen is visible and am I audible? Yeah. All right, guys. We can start. So I hope you have practiced yesterday's session. Let me recap what we have done till now in yesterday's session, and then we will continue what we are going to do for today. Right. So today's agenda is this much. Actually, this is the combined agenda for session 3 and as well as session 4. So session 3 we have almost covered all output parsers. We have seen what is string output parser, what is JSON output parser, and pedantic output parsers. We have also implemented those practically as well, right? After that, we have built a basic Langchain expression language. We have built a basic chain using LCEL. So that also we have done in practical, right? So after that, what we have done a document loaders. So several types of document loaders are available. So I have taken to you Langchain document loaders document, and then I have shown n number of document loaders. But practically we have seen how to load text files into our program, right? And PDF files, PDF loaders we have seen, CSV loaders we have seen, and also we have seen web loaders as well, right? So after that, we thought to discuss text splitters yesterday. So unfortunately we couldn't cover text splitters. So today we are going to cover text splitters. So our first topic today is going to be text splitters. So we are going to see how to do character text splitting and recursive character text splitting, and what is the use of text splitting. So we are going to discuss in detail about text splitters, right? Once that is done, then we will move to a vector stores. So there we will discuss what is vector store, why do we need a vector store, what is the differences between a traditional database and as well as vector database. So once that is done, I will also take a couple of databases like Chroma Vector DB as well as a Facebook AI similarity search, which is also called as FIAS Vector Store. So these two examples we will take in practical and see how to insert vector documents and how to modify the documents and how to get documents. All these CRUD operations, how to perform, we will discuss in the vector stores. Once that is done, then we will go to a retrievers, right? So there are multiple retrievers are available over there. We will see basic vector retriever, and as well as we will also see uh, Wikipedia retriever. Then I will take you to the official document and I'll show you n number of retrievers. You can just go and explore. Right. After this, we will discuss what is RAG. Right. So till now we are covering document loaders, text splitters, vector stores, and retrievers. There is a purpose for reading all this, for knowing all these components. So these all components will be used in RAG application. So we are going to discuss in detail what is RAG, and also we are going to implement a simple RAG application using Pinecone vector database. So technically we are going to cover three kinds of databases. One is ChromaDB and one more is Facebook AI similarity search, and as well as a Pinecone database. Right. All right. So if it is clear, we will move to our practical session. Right. So first things first, we need to discuss today text splitters. Right. So what is a text splitter? So yesterday, if you observe, we have loaded documents using text or PDF. Several document loaders we have seen, and if you observe carefully, you can see that if you take a PDF loader, right, uh, each page each page will be each page having one document. So each page content one document is having one page of content of PDF, right? So which will be huge sometimes. So when you are converting this text to embeddings, we have seen in session 1 what is embedding. Embedding is nothing but a numerical representation of text, right? So numerical meaningful representation of text. So if text length is more, then you cannot capture a meaningful numeric representation. So for that, what we need to split the whole text into small chunks, so that we will get a meaningful embeddings from your text. All right. So we will see in the practical, then you will come to know in a better way. So today we are going to cover character text splitters and as well as recursive character text splitters practically. We will also discuss semantic theoretically. I'm not going to implement semantic in practical. All right. So let us go to Visual Studio Code. So technically we are going to start text splitters. So let me create one new file called a text splitter. Let me create a new file inside rag folder. Name I am going to give as a character underscore text underscore splitter. I'm taking IPYNB extension, right? All right. So once you created a file, take a code block, then we need to do our uh, imports, right? So we have discussed yesterday PDF loaders. Today we are going to give a text splitter. So what we are doing, whatever content we have loaded from PDF file, that content we are going to split it. If you don't split, what will happen? If your text is more, you won't get a meaningful numerical representation. So to avoid that, uh, we need to split, right? So let me take imports quickly. So my first import would be from Langchain. Import Langchain underscore, sorry, from Langchain underscore text underscore splitters. Import character text splitter. Why we are importing character text splitter? Because we are going to see character text splitter. That's why we are importing character text splitter class, right? After that, we need to load some content. Either I can declare a variable and take a full content and then I can split it, or I can load it from my document, then I can split already loaded document. Correct. So let me take a PDF loader again from Langchain. We all know that all loaders are available inside Langchain community dot document loaders. We need to import, since we are loading PDF file, we need to import py PDF loader. Let me import it, py PDF loader, right? So once my imports are done, let me execute it. Let me select my environment as a lang tutorial. So even I will activate that here. Give me a moment guys. So all right, I have to go inside a lang tutorial and then scripts and then activate. Hit enter. Then my lang tutorial environment will be activated. All right. So I have successfully activated my environment, and I'm going to load my imports. Let me do one thing. So allow me a moment. It is going to connect to my kernel. There is some problem. All right, it started executing. All right, guys. So my imports are done successfully. Then what I have to do? I have to load my PDF file. So yesterday we have already seen how to load a PDF file using py-pdf loader object. So let me declare my loader first and then take py-pdf loader. I have to pass my file path over here. So what is my file name? My file name is, yesterday we have already seen. Let me copy it. Sorry. Uh, Let me copy the file name and then I'm going to paste over here. It is .pdf, right? So my loader is ready. Once my loader is ready, what I have to do? I have to load this document. For that, what method we need to use? We need to use a load method. So let me do it. Loader dot load. You can also use a lazy load, no problem. Load. So what this method does, this method load the PDF document and then it will return a list of documents that I'm going to store it inside docs, inside docs. All right. So till here, there is no confusion. We have already seen how to implement PyPDF loader yesterday as well. So now we are going to implement a character text splitter. So we have already imported character text splitter. So let me declare that character text splitter, character text splitter, and then it requires some arguments. One argument is separator, one more argument is a chunk size, and one more argument is chunk overlap. We'll see what is this chunk size, what is this chunk overlap, and then what is this separator, right? So first let me pass chunk size and chunk overlap. Chunk underscore size is going to be my first parameter. uh, Let me give it as a 100, and then I have to pass chunk overlap. Chunk underscore overlap is equals to, let me give the 0 and then I will play around with it. Then separator, let's see if it gives any error, we'll add the separator. So once this is done, so this I will this object I will assign to one variable. I'll call that variable as a splitter, right? Once this is done, what we need to do, we need to split using split underscore document function. So let me add that splitter dot split documents is going to be our function name, which will accept a list of documents, and whatever the parameter you are passing over here, based on that it will start splitting your text, right? So let me pass it first. Docs are going to be my documents, correct? So this will return, after splitting it will return all the values. Those values I'm going to store it in a variable called result, and then let me print length of the result. Length of the result. All right. So to understand what happened, I will also print length of the documents. Print length of docs. So yesterday we have already seen this file. This file is containing 6 pages of content. So each page will consider as a one document. So technically this docs variable will be having 6 documents, right? So length is going to be 6, and then we are passing this, list of documents to our character text splitter, and then we are printing what is our output length. So if you think our output length should be more than 6, so that conclusion we can come right now. Once execution happen, then I will tell what is this chunk size and what is this chunk overlap. So let me execute this first. uh, 1 second guys, there is some error. Generator has no length. Hmm, just a minute. So we have seen there is some error with this length. Just allow me a moment. uh, okay, let me see the type. Sorry, it should be load method. By mistake I have given lazy load. All right. So then I'm going to print the length. All right, yes. So let me execute it this time, and then you have see that uh, there are length of this docs are 6, and as well as result is also giving 6. Let me do one thing. Let me reduce my chunk size to 10, and let me pass my separator as well. SCPARATOR separator, I'll give empty character, right? So let me do it. All right, now you can see that the length of the documents are 6, and then the chunk size I have given 10, and separator I have given no space. Then I got 780 documents after splitting. Let me increase this chunk size and see whether my document length is going to increase or going to decrease. Let me execute again. So now you can see that my document length has been reduced from almost 600 to 800. Now let me do one more modification. Let me give 200 this time. So this time we know the game, it has to reduce further more. Let me see how it works. All right. So earlier it was 80. Since we increased chunk size to 200, now our document length are going to be 41. So at this point, I know you are not understanding anything. So let me show what is my uh, first document inside my result. Right. Let me see print, and then let me print result of 0. So first element inside my list I'm going to print. Right. Let me execute it. and you can see that. So my page content is having up to here. If you see my PDF loader, so my if I load first page, my page content is this much. But since I have given a chunk size as a 200, chunk size as 200, it has been trimmed my full page to up to 200 characters. So if you count these characters, your character length will be 200. Why it is 200? Because I have given chunk size as 200. So what we can conclude, this chunk size inside character text splitter means each chunk size represents one character. So let me show you clearly. Let me give 10 this time, and you can see your page content, it will reduce further more. Now you can see page content is simply, it is energy MET. Why it is only energy MET? Because you are telling split this text for every 10 characters, every 10 characters. So that is what this chunk size means. Now I hope you got the you got it. What is chunk size? Chunk size represents a character length to be trimmed. Since I have given 10 here, you can also count it. Let me do one thing. Let me print a length over here. Print length of, sorry, length of result of 0 dot, it is page underscore content. Correct. So let me print only page content here as well, so that there will be no confusion. All right guys, let me execute now. Now you can see my total documents. When I load my PDF file, I have loaded 6 documents. Once I have given character text splitter with character size 10, I got 780 documents as a response. After that, I am printing I am printing first page content, first documents page content. What is the page content? Energy meter. And then if you see the length of this first documents page content is 10, because I have given chunk size as 10. So now let me play with it. Let me give a 20 over here, and then you can see that your let me comment everything. Now we don't need this length of documents, because this is not going to save, this is not going to change, right? It will be always same, since I am not changing any file. And this is going to be changed for right now. To understand in a better way, I'm going to comment this as well. Now we will get only page content, and as well as length of that first page content. So let me load it again. Now you can see that since my chunk size is 20, it has been you know trimmed my each page content to 2020 characters, 2020 characters. So if you see here, if this is my first document, this is going to be it will calculate 20 characters and then trim. Then it will calculate 20 characters and then it will trim. After that, it will calculate 20 characters and then it will trim. So this is how character text splitter works, right? I hope chunk size is clear, right? Now let me see what is chunk overlap. Chunk overlap. Now this time I'm going to again see the length of the result, and chunk overlap I'm going to give a 10, and then chunk size I'm going to give 100, and then let me load it. Now you can see that I got completely uh, 88 documents as output. In that, first document should be having a chunk size of 100. Chunk size of 100. So what is the first document? First document is containing this much content, and this is going to be length of this document. Now let me print a second document as well. Print, let me comment this length, and then I'm going to print second document. Execute it. Sorry. Let me comment it, delete it. All right. So let me give one space over in between so that I can identify. Yeah, see that you can see guys. So this is my first document. This is going to be my second document, and 88 is going to be my total length. Let me delete that as well, and let me run again. So now you can see that this is going to be my first document and this is going to be my second document. If you count the length, this is going to be exactly 100. Every document will be having 100 characters in it. Then what is this chunk overlap? If you observe closely, first document has been ended at describes, correct? And then second document is also started from describes. So if I give chunk overlap 0 and observe the result, this won't happen. So it ends again at describes, and then it started with the next character. The system designed for a large scale energy meter platform that connects up to 1 lakh field devices. This is how uh, output we got when I give chunk overlap as a 0. But if I give 10, it will do, instead of starting from D, it will go to 10 characters behind of first document. So first document ends with describes, it will count 10 characters, and that 10 characters also overlaps and takes into second documents. So this is how character splitting will happen. So chunk size is going to be 100 and chunk overlap is 10. So generally, whatever chunk size you give, chunk overlap, it is always better to keep between 10 to 20 percentage. 10 to 20 percentage. Let's say if you are keeping chunk size as a 1000, then your chunk overlap can be varied between 100 to 200. And you can sometimes you can also ignore it, is completely optional, up to you. But for a better uh, rack performance, you have to keep 10 to 20% as your chunk overlap, right? I hope character text splitter is clear for everyone. If it is clear, then we will move to recursive character text splitter. Let me do it for 200. Or 10, and let me keep it 0. Alright, yes. So let us take new file and then we'll see how recursive character text splitter works. Let me take the new file and write recursive underscore text underscore splitter dot ipynb. All right. Right. So let me take the imports first. So since we are doing character text splitter, we have imported character text splitter from the text splitter. This time we are using a recursive character text splitter. So obviously we need to import recursive text character splitter from the text splitters. So let me take both the imports, and then instead of character text splitter, this time I need to import recursive character text splitter, right? All right, let me import this, take this to my environment, and then same, we are going to load our file first. Let me load my file. My imports are done. I have loaded my file successfully, and then I have to use the splitter. But this time what I'll go, instead of a character text splitter, I will use recursive character text splitter, right? In this case separator is not required. Instead of character text splitter, I have to use recursive character text splitter. So chunk size I'm going to keep 10, and chunk overlap I'm going to keep 0 as well. So why I'm keeping same values, let me explain. If you see this output, you can see that energy met, er plat for means in character text splitter it won't wait for the word completion. So word, it doesn't matter whether that particular word is completed or not completed, it will just count 10 characters and then start splitting. So that's why you have seen this meter is a one word actually, but since you are using character text splitter, this these words are not this is the not right strategy, because in between word breaks are happening, right? These cases you can avoid in recursive text splitters. So let me show you recursive text splitters with the same values. Chunk size is a 10 and chunk overlap is a 0, and then see the output, then discuss what recursive character text splitter does to perform better than character text splitter, right? Let me execute it. All right, now you can see guys, the first chunk will be having energy and second chunk will be having meter. Second chunk will be having meter. So what will recursive text splitter does? Recursive text splitter does try to chunk page by page first. If your chunk size is less, then it will try to chunk paragraph wise. Still your chunk size is less, then it will try to break word wise. So that's why if you use recursive character text splitter, most probably you won't get a broken words in between. So let me see the same example with 100 and chunk overlap as a 10. Now you can see that the first document has been ended up to introduction. But in case of character text splitter, where it got ended somewhere else. But recursive text splitter thought that because every line break it will consider as a new document. If that line break fits into your chunk size, it will consider as a document. So I know you don't understand at this point. Let me do one thing. Let me take you to some Streamlit application. So this is the Chunkwiz developed by some third party guys. So what you can do is you can play with character text splitting as well as recursive character text splitting. So let me do one thing. Let me add some. Let me quickly add some words there. Allow me a moment. So let me add guys. I am Naresh working in Euron, and then I'll take a line break. I'll take a line break, and I will add some more words like I live in Bangalore. I live in Bangalore. So first I am taking character text splitter and chunk size I am going to give 10. Overlap I am not going to give anything. Now you can see what this character chunk splitter does. It will count first 20 characters. What is the first 20 characters? First 20 characters will come up to working, then space. So this color, I hope it is visible. Let me zoom it 1 second. All right. So you can see that up to I am Naresh working is going to be my first chunk. In Euron, I live in B is going to be my second chunk. Whatever left over, it became third chunk. You can clearly identify that this is not a right strategy, to do chunking, because in between, it doesn't matter whether it is a sentence or whether it is a paragraph. In between, it will break. It might be in between word, it might be in between sentence, or it might be in between paragraph. Chunk character splitter doesn't care anything. It will strictly take that particular character and will start splitting. That's why recursive character text splitter came into the picture. And the way how it work, it will try to fit first paragraphs wise. If not possible, it will try to fit in sentence wise. If still not try to fit, then it will go for word wise, so that you will get a meaningful, chunks if you use recursive character splitter. So let me take recursive character text splitter and show you the same example. Then you can identify the difference between character text splitter and as well as recursive character text splitter. So let me do now. See, since I have given a 20, it has breaked. I am Naresh up to working. It has breaked as a one chunk. Then in Euron, it has breaked into second chunk. Then I live in Bangalore is going to be my third chunk. Compared to previous case, right? So why, if you observe closely, in first, since I have given chunk size 20, it may not be having 20 characters, because if you see that I is going to be one character, space is going to be a second character, am is going to be 2, so 2 plus 2 4, and then space 5, and then Naresh 5 plus 6. 5 plus 6 is going to be 11. Correct. 5 plus 6 is going to be 11. And then space 12. 12 plus working. Working is going to be 4 plus 3. 7. It is 19. It is 19. Since it has word completed here, it it didn't wait for a 20th character. It considered up to working as a my first chunk. In case of second, in Euron, I have, if you count my characters, I have only 1 plus 2, 3, plus 1, 4, and then plus 5, 9, right? So technically, I live also should come into my second chunk. But this recursive character text splitter won't consider it, because there is a line break after Euron. There is a line break after Euron. So it is considering I live in Bangalore as a complete new line. That's why whatever left over here, it is not going to add your new line into your previous line. So it has treated I live in Bangalore as a separate line. That's why it ended the second chunk with only 7 or 8 characters. Then I live in Bangalore, which will be obviously before 20 characters. So that's why it is added as a I live in Bangalore separate chunk. So this is how you can have a meaningful chunks compared to character text splitter. So most probably you will be using recursive character text splitters in any RAG based application. Why? Because I have shown you the demo. Uh, Recursive text splitter is performs better than character text splitter in chunking. I hope it everyone got this point. All right. So this we have done this. We have done up to PDF, PDF chunking, right? So there are, if you have any, Python code, if you have a JavaScript code to be chunked, if you have Node.js code to be chunked, or if you have a C code to be chunked, there are different approaches are there in recursive character text splitter. Inside recursive character text splitter, you have a parameter called language. If you mention that language, it will give list of language options, whether it is Python or whether it is uh, JavaScript. You can specify. So according to that, it will try to do character text splitting, right? So let me show you that as well. Allow me a moment, guys. So let me take you to the document and then show you what I was talking about. Recursive character text splitter. If you type, Langchain document will be open. You can simply go there. Sorry, this is, I think it is not official document. Langchain. text splitters inside Langchain. So try to follow official document because you can get n number of documents which will lead to confusion. So this is the text splitters, right? So inside text splitters, we have a length based, which is character text splitter. We have already discussed. We have a document structure based. So let's say if you have a HTML code, if you have a code, if you have a JSON file, you can also follow. Let me quickly show you split code. So inside text splitter, you have to import language option. In the language, you can specify what kind of language you are going to split. See, if it is a plain text, you no need to specify any extra parameters. If in some cases you are going to split your JavaScript code or your Kotlin code, your Java code, in that case, you have to import this text splitters language and you have to specify that particular language as well, so that uh, this algorithm will work according to that programming language, right? So this is what I wanted to clear. I hope it is clear. So you can see over here, these are the languages it supports currently. Now you can see, uh, once it is done, recursive character text splitter, you have to take a method name called from language. Chunk size and chunk overlap is going to be same. Whatever you want, you can give, whether it is 100 or 0 chunk overlap, or 1000 or 100. It is according to you. Then you have to specify what language it is. If it is a Python language, you have to specify Python. If it is a JavaScript, you have to specify JavaScript. For text based, you no need to do this from language option at all. Since I wanted to show that, so that in case if you want to split any programming based language, then you can use this method as well. So this is how about character text splitter and as well as recursive character text splitter. So one more text splitter is there, which is a semantic text splitter. Nowadays it is going to popular. In semantic text splitter, what they will do, uh, they will send a full text to the LLM, and LLM will decide. Let's say in general cases, your paragraph can be talking about different topics, right? Different topics. In that case, your recursive character text splitter may not be aware, because recursive character text splitter is just an algorithm. It follows some rule. But in case of semantic, what will happen? Your text will go to the LLM, and LLM will try to understand your text based on whichever is a meaningful text. It will break as a one chunk. Then whatever not meaningful, it will break as a another chunk. So what I was trying to say, let's say in one paragraph I am talking about myself. In the same paragraph I am talking about Euron, right? Let's say, uh, let me show you. So in one sentence, I'm talking about myself. I am Naresh. I live in Bangalore, something like this, right? Then I will talk about Euron in the same. Euron is an institute which provides multiple courses at single subscription. So if you use character base, if you use recursive character text splitter, all these are rule based text splitters, right? But if you use semantic, what will happen? This text will go to LLM, and LLM will try to segregate. Okay, I am Naresh and I live in Bangalore. This is going to be first chunk. This is going to be first chunk, because here is only talking about Naresh, and then this will going to be a second chunk, because this uh, this sentence is talking about only Euron. So why it will happen? Because LLM knows that what user is talking about, right? Because they have trained with massive data. They can identify this is talking about Naresh and this is talking about Euron. So this is going to be my one chunk and this is going to be my another chunk. But in the case of character or recursive character text splitter, you don't get that intelligence. Anyway, this semantic is still under research. I think in production applications they are still not using this semantic. Maybe in future they might use this if it gives good results, right? So with this we can close character sorry we can close this text splitters. Then our topic is going to be a vector store. Vector store. As if you have any questions you can ask, I will try to answer. No questions, right? Let us discuss what is a vector store. Just allow me a moment, yes. All right. So what are vector databases? See, vector databases stores embeddings. What is embedding? Embedding is nothing but a vector representation of text, or simply you can say that a numerical representation of text. If you remember, in class 1 we sent some text to the embedding model. So embedding models are special models, unlike traditional llms, traditional languages. What traditional llms works, how it works, it will take input as a text and it will give output as a text. But embedding models works different. It will take text as an input and then it will give output as a numerical data as output, which contains a semantic meaning of the text you have passed to the embedding model. So I hope this is clear. So what embedding is nothing but a vector representation or a numerical representation of a text, right? So why do we need this numerical representation of text? Uh, Guys, if you see traditional databases, we have several databases, right? Traditionally we have SQL database. If you come NoSQL database, we have MongoDB, we have DynamoDB, we have Cosmos DB, and we have PostgreSQL. There are several databases already exist in the market. Then why this suddenly vector databases has been introduced? So if you observe these traditional databases are designed for a structured data, to store structured data. Either you will store the data in tabular format with for SQL based databases. If it is no SQL based databases, you will store the data in uh, JSON documents, right? So this is how this traditional databases works. So there is no special capability of storing vectors inside these databases. Even if you store these vectors, there is these databases won't allow you for semantic similarity search. So what is the semantic similarity search? So let me tell, traditional database what will work. Traditional database allow you to search something based on a keyword. Let's say you have a products table. you have a products table you have a product name inside, you have a product id, you have a product price, and you have some product description, correct? So these four uh, columns you have in a table. Let's say as a user as a user I came and I asked you about product 101. What you will do? Select right? What you will do generally, you will write a select query, select star from products where product ID is 101. Then what will happen? It will try to find out that 101 product ID in your database, 101 product ID in your database, and then will give you the result. This is how any traditional databases works. Or you can ask the product name. You can ask the product name. Let's say I want a Samsung mobile. I can ask for Samsung mobile. Then my query is going to change as select star from products where product name is Samsung mobile. Correct. So this is how this works. Let's say I have a different requirement. I have a different requirement. I want to get the mobiles. I want to get the mobiles, which is, you know, which is good for gaming, but I don't have any separate column saying that these mobiles are good for gaming, these mobiles are not good for gaming. But but inside my product description, inside my product description, I specially mentioned these devices are having 16 GB of RAM, 16 GB of RAM, so that these are good for gaming. These are good for gaming. So somewhere it is there in my product description. You think of this situation. Think of this situation. With this information, can you query your traditional databases? Obviously, no, it will not at all work, because here you are not doing keyword based search. You are not doing keyword based search. You are instead you have to do semantic similarity search. So this kind of capability traditional databases will not be having. So that's why these vector databases came into the picture. Now, if the same query, if you take it into vector databases, what will happen? You will have, let's say, you will have five products in your vector database. These vector databases will be having numerical representation of these five products. So whenever I search something, what this vector database does, it will find semantically which is a nearby, which is semantically nearby. So any high-end model or any gaming mobile is available inside my products, it will try to pick, even though we are not giving exact keyword as a parameter, we are just passing some text. It will try to convert that as a numerical representation, and it already having numerical representation of several products. It will try to match which product is nearby to this vector. So if it is nearby to this vector, then it will fetch and give you the vector databases. So this is how vector databases works, right? So what are the popular vector stores we have in the market? uh, Popular, we have a Chroma database, uh, which will be simple, lightweight. You can also, you can also install in your system, which is open source also. You can import that, and then you can store all your vectors inside ChromaDB. So that we will see in practical, how to convert a text into vector and then store these vectors into a ChromaDB. Also we have FIAS, which is also called a Facebook AI similarity search. So this is also this is called in-memory database. So since you will store all these things in memory, your search similarity search is going to be very fast, because you are not depending on any external database over here. Then we have Pinecone, which is cloud based, obviously. If it is a cloud based, you have a several options will be available. You can scale it to millions or billions of vectors. In case of FIASys, it may not be possible, it might be possible, but you need, high computational servers, right? So to remove all these headaches, Pinecone came into the picture, and they are offering, you know their vector databases. What you need to do, how you will do in AWS, you will just go, you will create an account, and you will start spinning up EC2 machines. Like that, you will go to Pinecone website, you will create a vector database. You will start, you know, dumping your vectors, and you will start retrieving your vectors. So this is how Pinecone works. So I'm going to cover all these three. Apart from this, we have another vector databases as well, like Waviat, and there are several vector databases, but these are popular and mostly used vector databases. So we are now we will go to Google Colab and see how these databases works. All right. So let me go and type Colab. You know, right? Google Colab is a free notebook tool where why I'm taking this, because now I'm going to insert this chroma db, right? So if I insert into my system, it may become slow. That's why I'm using a, a notebook from Google Colab. So let me create new notebook. You can also use this. It is absolutely free. In case if you have a good system configuration, you can also do it in your local system as well. All right. So once you have taken this, what I'll do, I'll quickly install dependencies first. So let me do one thing. Let me install all the dependencies. So if you see the dependencies, what I am doing, I am installing Langchain because, you know, Langchain we have installed in our local system. The problem with Google Colab, whenever you open Google Colab, you know, this system doesn't have any packages, right? Every time you open, you have to install all these packages, and then click on connect here. It will connect it to some machine. Then I'm going to install these packages. My first package is Langchain, and then I'm installing one more package called Chroma DB, because we are going to use ChromaDB for vector insertion and as well as retrieval purpose. Then I'm using OpenAI for generating vectors or embeddings, and other PyPDF file and Langchain OpenAI Langchain community nodes packages also I'm going to install. Let me quickly install it. These files I'll be shared so that after class you can find it in a GitHub link. So let it install completely. All right. So you can see that all packages has been installed successful. And let me take a new code node. Since we are using OpenAI, we need OpenAI API key. Instead of OpenAI, you can also use any embedding models. Google also support embedding models. You can use that as well. Since we from session 1 we are using OpenAI, so I'm going to continue with OpenAI itself. So what I have done, I have imported OS package, and then I'm setting my Open API key inside my environment. So done. So this is done. Now what I'll do, I have to do these imports. My imports are going to be OpenAI embeddings. Let me write it. So from Langchain, from Langchain OpenAI package, what I need to import. See, we no need to import chart OpenAI because we are not using LLMs this time. Instead, we are using embedding models. If you remember first class, we have imported OpenAI embeddings instead of chart OpenAI, right? So let me import that. Import OpenAI embeddings. So why OpenAI embeddings? Because we are going to send text to OpenAI embeddings, and OpenAI embeddings will return us vectors or embeddings or a numerical representation of a data, right? After that, what we need, since we are using ChromaDB, we need to import ChromaDB as well. So where it exists inside from Langchain dot vector stores. Inside Langchain vector stores, we will be having chroma. Import chroma db. It is not chroma db, it is simply chroma. Uh, I think some spelling mistake. Let me do one thing. Import chroma. Right. After that, what we need, we are going to import a special data type called document data type, which we have discussed in yesterday's session. So this will be available inside langchain.schema package. What is document? We know, right? Document contains two properties. One is space content and one more is metadata, right? So let me import these files. Yeah, these packages are imported successfully. Now what I'll do, I will take some hard-coded documents instead of loading from a PDF file. So I have already declared these documents. Let me quickly copy and paste it over here. Just a minute. Let me take a new code node and then paste it. All right, we have already imported this. So what I'm doing here, I am taking some documents. See, now if you load from any PDF, finally you are going to get only these things. Inside document, it will be having page content and also it will be having metadata, right? So instead of loading from PDF file, what I am doing, I am hard coding some values. What I have taken pizza is one of the most popular foods around the world. With soft base something I have written about pizza, and category in metadata I am assigning category as a Italian. In document 2, what I am doing, I am talking about burger, and category I am assigning as a American, right? Similarly, I have a document 3 where I am talking about some dish, and this dish is going this category is Japanese category, right? And then what I'm talking about masala dosa, which is Indian category, and paneer butter also Indian category, and I have a biryani also Indian category. So like this, I have 8 documents. Doc 8. So doc 1 to doc 8. I have 8 documents and all I have kept inside a list. So my docs will be having list of documents. This you understood, right? So let me execute this block. Nothing much I am doing here. I have hard-coded some documents and then I am passing all the documents inside a list, and that list I am going to assign into docs variable. So once this is done, what we need to create a vector store using chroma. We need to create a vector store using chroma. So this is the code for chroma. So you have to define a chroma class. Inside you have to pass embedding function. What is embedding function? Embedding function expects an embedding model. In that case, what I am passing OpenAI embeddings model. Or you can simply, what you can do, you can create embed model is equals to OpenAI embeddings, and this embed model I am passing inside my embedding function. So what you need to do inside embedding function, you need to pass one embeddings model reference, right? I have passed that model reference. After that, what you have to do, you have to give a directory name. In my case, I am giving my chroma db. Collection name you have to give. It is like, let's think like persist directory is going to be your database name, and collection name is going to be your table name. Clear, right? All right. So once this is done, if you see my collab, inside only sample data is available. After you execute this, it has to create a folder called my chroma db. Then you can see that chroma has been successfully installed. Let me see, let me execute it. All right, once this is done, you can see that my chroma db has been created. If this has been created, it means all your data will come and store into your my chroma db directory inside collection called sample. Till here it is clear, right? So now what I have to do, I have to add documents. I have to add documents. What are the documents I am having? I am having 8 documents. Let me close this. Let me take a new code and then paste it. So what this docs contains? This docs contains 8 documents. All these 8 documents, I am going to store it inside vector store. Right? It is clear. Let me execute it. All right, guys. So you can see that 1, 2, 3, 4, 5, 6, 7, 8. Why I got 8 IDs? Because I have inserted 8 documents inside my vector store. Inside my vector store. So let me show you what my vector store is containing. What my vector store is containing, right? So let me take new code block and then click. So according to you, what it will be having? You will be thinking that this vector database will be having page content and as well as metadata, right? So let us see, apart from page content metadata, any extra things present over there. You can see IDs are present over there, which are extra because system has been assigned IDs, and we also got these IDs over here, right? Apart from IDs, you can see that there is a special key called embeddings, where it is storing numerical representation of your numerical representations of your text. How these embeddings comes? We are not calling any embeddings function, right? If you see here, this vector store, we are assigning one embedding model. So whenever you do add documents and you pass docs, whatever the page content having inside this docs, it will go to your embedding model, and your embedding model will convert text to a numerical representation of data, and it will return. So those values will be stored over here. So those values will be stored over here along with your page contents as well as your metadata, right? So this, you can see over here, metadatas are here and your page contents are this, and along with this there is a extra called embeddings also present over here. So I hope this is clear how this embedding comes. This embedding comes because of this embedding model. So every time your Chroma database will call this embedding model and will get equivalent numerical representation of that particular text, and it will insert that text along with your original page content. So this is how these embeddings we get. Now, what other operations we can do? We have successfully did. Uh, what we have did? We have successfully inserted these documents inside our DB. Uh, now what we can do? We can start querying our DB. We can start querying our DB because our vector DB is having some data inside it, and we'll see how this querying is different from traditional databases. So let me do one thing. Let me take a new code node. Uh, Give me a second. Let me take new code node and let me ask a question. That question you need to ask to your vector store, and vector store dot, you have to use a function called, earlier we have used add vectors. This time we are going to use a different function which is called similarity search, which is represent which what it will do, it will take a query as an input, and then it will try to find out a meaningful nearest document regarding to your query, right? So let me pass my query first. What I have to do, it will accept couple of parameters. One parameter is going to be my query. So what I'll do, I will ask which is South Indian breakfast, which is South Indian breakfast. See, if you ask same question with the traditional databases, traditional databases will fail to answer this question because uh, those are not implemented for this purpose, right? They have implemented for a different purpose. Vector stores are implemented for searching meaningfully nearby vectors. So now, along with this, you can pass one more parameter called k, and you can pass either 1 or 2 or 3. What is this 1 or 2 or 3? So currently you have 8 documents. Currently you have 8 documents. So it will try to give a nearest 2 documents. If you specify k value as a 2, it will try to give nearest 2 documents. If you specify 3, it will try to give nearest 3 documents. Nearest 3 documents. So let me fetch 3 documents which are near to my query, and my query is which is South Indian breakfast among with this 8. So obviously I am expecting masala dosa should be there, and then might be some other, maybe biryani or something else. Let us see what output it will give, and then we'll discuss. Now let me enter execute this. Uh, which is South Indian breakfast, invalid. Yeah, sorry, I forgot the comma. Let me give the comma and then execute. Now you can see you got 3 documents. This is one document, this is second document, and this is my third document. I hope it is visible to everyone. Let me increase my font size. Right. So this is going to be my first document, and this is going to be my second document, and this is going to be my third document. Why I got 3? Because I have specified k value as a 3. If I give k as a 2, it will give nearest meaningful answers of uh, 2 instead of 3. Let me execute it again. And now you can clearly see I got only 2 outputs. If you want only one, you can give 1 as well. Then you will get only one document as an output. Right? You understood what is this k value and how it works. Generally, you have to get a multiple because sometimes uh, it may not capture meanings correctly. So always better to get multiples. Better to be 3 or 5. Let me give 3 and then execute. So this is going to be uh, similarity search is going to work. If you see the outputs, you can clearly identify masala dosa is obviously a South Indian breakfast, and others it got paneer butter and as well as biryani. Why paneer butter and biryani? If you see other dishes are American based, right? Other dishes are American based, Japanese based, and so on, right? So obviously those are not meaningful when I ask particularly about Indian breakfast. So that's why you got only these 3 documents. All right. So now we have seen similarity search, how similarity search works. We can also have one more method called similarity search with score. Similarity search with score. So what it will give, we will see. Let me do one thing. Let me ask same question. Let me take a code node, paste it. This time, instead of similarity search, I will similarity search. You can see that similarity search with score is going to be my function. What it will do, it will give you the document, and also it will tell you how similar these documents are to your query, right? So let me execute. Obviously I am expecting masala dosa is going to be more similar compared to paneer butter or biryani, right? So let me execute this. Sorry, not this one. Let me execute this block. All right. So you can see that masala dosa similarity score is 0.27. So obviously, which is if it is nearby 0, it means it is closer to your question. So obviously, this is closer to my question. And for paneer butter, it has given 0.42 as a score. And for biryani, it has given 0.43 as a score. So you can clearly identify that for our query, masala dosa is the nearest answer, nearest content. Correct. So this is how similarity search works in Chroma DB. Right. Now you can also do couple of things. What you can do, you can also filter based on category. You can also filter based on category. Till now we have added we are not added any filter. So let me add the filter and then show you. Now what I'll do, I'll take a new code block. Now instead of asking query, direct query, this time I am filtering with score is not required obviously. I am filtering like a traditional database where category is Indian. So give me the dishes where category is Indian. So this functionality is also available inside your vector store. So you can see that whichever category is belongs to Indian, those records or those embeddings will come as a output. Right. You can see three outputs I got and all three are belongs to category belongs to Indian. You can also ask American whatever you want. So now this is done. If you want to update the document, if you want to update the document, you can also do that using update document method. So let us see. Let me take a new code node. This time what I'm going to do, I'm going to update my first vector with new text. So you can see if you see my previous first document, it was this pizza is one of the most popular comfort food, something something was there. Now what I will do, I will try to you know change something. This I'm going to delete this and I'm keeping only one line of content, and category I am keeping Italian as it is. For updating the document, you required document ID. Where you will get the document ID? So when you inserted your documents, you got all document IDs. Also, you can get the documents when you search, when you do get operation, all IDs will be listed. So this is going to be vector ID for my first record, right? So what I'll do, I'll replace my document ID here, over here. So what I'm telling, inside vector store, update the document with the document ID this, and what is the document? The document is going to be updated document. What we have updated? We have updated page content. If you want, you can also update metadata as well. So let me execute it. Now you can see that it has been executed successfully. To cross verify whether it has updated or not, what I will do, I will I will check that vector stores dot get of we need to pass all includes what and all to be included. So give me a moment. All right. So if you want to see only particular embeddings, you can check only embeddings. If you want to see only documents, you can pass only documents. If you pass metadatas, it will give only metadatas. So in this case, I want to see all. So that's why what I will do, include all parameters and then enter. Now, if you observe the first document, you can see pizza is one of the most popular comfort foods around the world. Nowadays, a very popular in India. So this is my updated document. So I have successfully updated my documents inside vector DB. You can also do a delete operation as well. So for that, you have to call a delete method and then you pass the ID. So let me quickly show you that as well. Take the code node, take your vector store reference, vector store dot, you are going to perform a delete operation. Inside delete operation, you must to pass IDs in array. So if you want to delete multiple documents, multiple IDs also you can pass. So let me pass my first ID over here so that that pizza document will get deleted from my Chroma DB, right? Let me pass it. I have passed it and then hit enter. So it has successfully deleted. For cross verify, let me execute the same line again. Take the new code node. 1 minute, guys. Take the new code node and then hit enter. Now you can see your first document is not going to be pizza. Your first document is talking about burger because the document which represents a pizza has been deleted successfully from your Chroma DB. So apart from that, this is about Chroma DB, guys. So I'll share this file after this session. Just go explore, try to add your own documents instead of hard coding documents. Try to load any PDF file, try to do chunking, and then try to insert those documents into Chroma DB so that you will get a better exposure. Right? I hope it makes the sense. Then let me explain you how Fias works as well. So both work similar way. So let me quickly take a new notebook. So again, every time you take a new notebook in Google Colab, you must install all packages because as soon as you leave this Google Colab, all packages will be deleted permanently. So I suggest you use Google Colab only for practice purpose, right? All right. So you can see right click over here. It means it has been up and running. Then I can start installing my packages. So this time I'm going to install a Fias CPU version. Fias comes with two versions. One is CPU and one more is GPU. If your system supports GPU, you can install Fias GPU. If your system won't support GPU, you have to install Fias CPU version, right? And apart from along with that, I have installed Langchain OpenAI Langchain community packages as well. So these are simple installations I have done. And then let me take the new code node. Once installation done, uh, since in earlier case also we have seen what we have seen, we have assigned our OpenAI API key. So let me take these keys. So every collab works individual. So this key will not be available inside this collab notebook. So you have to load it again, right? Uh, 1 minute, guys. All right. So this is done. Once it is done, what we need to do, we need to create, we need to import our packages, right? So let me take a new code node and then import. This time what I'm importing from Langchain vector stores, I am importing Fias database. Earlier we have imported a Chroma DB because we are going to work with Chroma DB. That's why we imported Chroma DB. This time we are going to work with Fias vector store. So obviously we need to import Fias store. So all are available inside langchain.vector stores package, right? And these are common from Langchain OpenAI. We are importing OpenAI embeddings because we need one embedding model. And then we are importing a document from langchain.schema because again we are going to declare some documents. So for that purpose, we need to import document as well. So once this is done, same documents I'm going to copy again. Let me copy it quickly. Take a new code node. I'm copying and keeping same documents again. We have 8 documents, right? Same 8 documents I have copied and then assigned inside a docs variable. Now, once this is done, we have to create a vector store with Fias. A vector store with Fias. So what you have to do? Take a new code node and then you have to run this node. I'm taking vector store as a variable. which holds this Fias vector store inside a vector store variable. Fias dot from documents is the method, and I am passing documents. These are my documents, and also I am passing one OpenAI embedding model. You can also assign this OpenAI embeddings to some variable, and you can pass that variable so that same embedding model you can use multiple times. So if you don't want to use multiple times, you can directly pass OpenAI embeddings instance to this vector store. So since it works on it stores data inside RAM, unless like ChromaDB, it won't require any your file access. That's why I'm not giving any directory name over there, right? Once this is done, so your Fias vector store has been created successfully. Now what is the next step? Next step is going to be adding our documents. Adding our documents. What we have done earlier? Earlier, we have taken a vector store reference, correct? Vector underscore store. For adding documents, you need to use add underscore documents method to insert documents inside your vector store. Keep dot and then use add underscore documents. It expect a list of documents. What we have done, this is the list of documents. As it is, you can pass over here, or since we have already stored it in a docs variable, just copy it and then paste it over here. All right, then hit enter. Now you got the IDs of each vector. Since you have inserted 8 vectors inside your Fias vector store, it has given 8 uh, IDs of that particular things. Now what we will do, we will quickly see a search and a similarity search as well as similarity search with score for the same question what we have seen earlier, right? So let me execute it. Now nothing has been changed, right? So similarity search function is same, the query parameter is same, and k value is same. How many documents you want in response you are mentioning here. So this is the beauty of Langchain. So let's say you have used Fias in your project, and let's say tomorrow you want to change from Fias to ChromaDB or from ChromaDB to another vector store. You no need to change much of your code, right? Because only your vector store declarations will change, rest everything will work same. So that is why uh, we are using these frameworks simplifies our life better, right? All right, so you have seen that same output I got, masala dosa. So I don't know, for some reason it is giving 2 times, and biryani as well as output biryani I got. All right, so now what I'll do, I will check similarity search with score. This time I'm going to change my question and see what output it does. Let me take a new code node and then paste it. So what I am asking this time? This time my question is, which dish is based on rice, right? Let me execute. Obviously, I am expecting biryani. All right. So you can see the output. It has given 3 documents because we have mentioned 3. If you mention 2, it will give you only 2 outputs. Correct. This is the first document and this is my second document. And document ID, metadata and all given. So biryani is going to be my first one. So 2 times it has given biryani, and you can see the similarity score 0.330. Right. So let's say if I give 5 and then execute, now this time I get 5, and you can see the score. For biryani it is 0.33, and for other it is going to be 0.41 and 0.42. So by this we can conclude that biryani is meaningfully nearby to our query. That's why it got less similarity score and it is closer to 0. All right, guys. So this is how you have to implement ChromaDB or Fias DB. So one more DB I'll show you, which is a Pinecone DB. So this is not since it is a cloud-based vector store, we have to follow some different approach when we are seeing rack-based application. That time I'll show you how to insert documents inside your Pinecone. First of all, I'll show you how to create an account how to get API keys. Since it is in a cloud, you required API keys, and you have to create one database, create one collection. You will be having a GUI option. I'll show you step by step how to use Pinecone when we are building a demo application. Right. I hope it is clear. Already. So with this, what we have covered, we have successfully covered most of the things for today. Let me show the agenda. All right. So we have covered text splitters and we have covered vector stores, and one more thing is pending over, which is retrievers. Right. So let me go and show you what is retrievers in Langchain and why we need these retrievers. Right. All right. So you can see over here what Langchain is giving the definition. Langchain is defining a retriever is an interface that returns documents given an unstructured query. It is more general than a vector store. A retriever does not need to be able to store documents, only to return them. Retrievers can be created from vector stores but are also broad enough to include Wikipedia search and Amazon Kendra, etc. So, in simple words, a retriever is responsible for retrieving documents data store from data store. That data store might be anything. That data store might be vector store, or it might be a Wikipedia server, or it might be Amazon Kendra. Whatever it is, what will happen? You will give one unstructured query. Like you will ask, what is unstructured query? Last time we have seen. Uh, Give me the disk which has a rice in it, right? That is a unstructured query. It is not structured query. So you will ask that question, right, to retriever, and retriever will get data from any external source, be it a vector store, be it a Wikipedia source, or be it a Amazon Kendra store, and then it will give you the output. That is what retriever's work is. That's it, nothing else. Retriever is responsible for taking your a raw query and then give you some documents as an output. This is a simple definition for the retriever, and we'll see how to implement retrievers inside Python. So what I'll do, let me take quickly a new file. Let me give it a new notebook. So if you see the document, they have mentioned couple of retrievers. One is Wikipedia search, and then Amazon Kendra, and then you can also get data from your vector stores as well. So since for rack based applications, retrievers we will use mostly for getting data from vector stores, but retrievers are not limited to vector stores. Retrievers can also work with uh, external data sources as well, right? So let us quickly see what this Wikipedia does, and then we will move to vector store. Already we have ChromaDB, we have FireDB. So we will try to implement, retrievers inside our DBs. Correct. So let me quickly do one thing. They are telling you need to install Wikipedia community, right? So what I'll do quickly all installations. So I have also included Wikipedia inside it as this document suggested. It needs Langchain community and also it needs Wikipedia. So I have included Langchain community as well as Wikipedia. And I'm taking Fire CPU also because this demo I'm going when after this Wikipedia, I'm going to use retriever with Fire's database. That's why uh, now itself I am going to install Fire's package as well. So let me run it. like this. So it has been installed successfully. So once it is installed, let me follow the document as well. One second. So once installation is done, they are telling import Wikipedia retriever from Langchain community retrievers. So let us quickly import it. For that, I have to take a new code node, paste it, and then they are also telling use uh, declare Wikipedia retriever class with a retriever, right? So let me do this as well. Let me do this as well. Copy it and then paste it. See why I'm showing this, because everything you will get inside the document. You just go to official documentation and start exploring all retrievers instead of because we cannot cover all retrievers inside our sessions. So that's why I'm showing the document, and also I'm showing how to implement these retrievers, right? So that you will get the a better exposure if you want to use another retrievers as well. All right, let me run this. So my retriever is ready now. Once my retriever is ready, what I need to do, I need to use invoke function and then pass my query to this invoke function. Correct. So let me take a new code and then go to document. If you see the document, they are telling the same thing. Use the retriever as a reference and call your invoke method and pass your query. Correct. So let me copy it and paste it over here. Let me call this as a result or docs, whatever it is fine. No problem. So invoke instead of this, what I will do, I will pass some random question. I'll pass Indian history. You can pass anything, right? Because in the end, you need to pass some unstructured query to the retriever. All right. So execute it. I'm not printing it. Let me do one thing. Let me quickly print this docs. Print it. All right, so you can see that a list of documents, you got it. So now you understand the definition. Retriever takes your unstructured query as an input, and it will query any DB. It might not be vector store, it might be uh, any external store, and then it will return some documents as an output. So the same thing it has done. We are querying Wikipedia retriever. We are using Wikipedia retriever and we are hitting Wikipedia server with a query called Indian history, and this retriever is getting some output and converting into documents, and that documents it is displaying over here, right? So all right. So if you want to see how many documents it has written, you can see print length of docs. I think by default some number it will return. I'm not sure. All right. So you have got 3 documents which is related to Indian history, right? So I think you can go to here and play with. See, there is a API reference for this. Click on API reference, and you can start implementing. Give me a moment, please. So you can start playing with the input output parameters, or let me over it. If it requires any other parameters also, we can. Yeah. So it you can pass multiple arguments. It will accept. I think one might be Langchain. If you go to the document, you can clearly get what arguments need to be passed. Uh, so this is how Wikipedia retriever works. Now what we will do, Now we have seen how Wikipedia retriever works. Now we will see how our retriever with vector store works. So for that we need to create one vector store. So quickly what I'll do, I will take some documents. So for taking documents, what I need to for taking documents, what I need to import the document. So let me take a new code node and then paste it. So from Langchain.schema, I'm importing documents. Now what I need, I have to import all my documents which I have used in before. Uh, in Chroma or in Fiasys, we have used some documents, right? Same documents I'm going to copy again, right? So you can see that again I have taken 8 documents, and those 8 documents I'm keeping inside docs variable. Why I'm seeing showing these things repeatedly means, see, uh, if you see repeatedly, and if you after this if you practice repeatedly, then it is very easy for you. You can understand these concepts in a better way. That is the only reason, so I'm repeating these steps again and again. Otherwise we can earlier file itself we can implement these things, but since I want to repeat these steps so that you will get the better idea. So let me take these docs. Once docs are over, what we need to do, we need OpenAI embeddings, and as well as we need one database. We haven't imported those things yet, right? So take the new code node and then import Fias database as well as import OpenAI embeddings. Once you imported all these things, I am going to declare one embedding model. Embedding model is going to be my OpenAI embeddings. Then I am going to create one vector store. So this will create a Fias vector store, and we are passing documents reference as a docs and embedding model as this embedding model. You can also replace with OpenAI embedding models over here. Once this is done, what we need to do? We need to do vector stores dot add documents. Vector store dot add documents. So let me quickly do it, and then I am passing docs. Now these docs will go to embedding models, and embedding model will give you numerical representation of each text, and all will be stored inside our vector store. Let me execute it quickly. Uh, 1 second, guys. There is some error. Langchain underscore OpenAI import. All right. We forgot to import the API key. So that is what I said. Whenever you take a new collab notebook, you must install and you must import all these things again and again. Otherwise, it will give you the error. So no problem. I'll do one thing. Let me add my API key. So what was the error? Error is saying that you don't have any OpenAI API key. So that's why I have added OpenAI API key, and then I have successfully executed. Now this API key will be available so that my embedding model will use that API key to convert text to numerical representation. Just click over here. Now you should get output as your IDs. It means what? 8 documents successfully inserted into your DB. Now let us query these things using a retriever. Earlier we have already seen, if you use vector store dot similarity search function or similarity search with score function, also you can get your output, right? But this time we are going to use a retriever instead of uh, direct vector store functions. Why? Because retrievers is a component which exists inside Langchain ecosystem. So when you are building chains, how we have seen string output parser, right? So we can manually also extract string from LLM output, right? Still we are using string output parser because which will give an edge when you are building uh, chains in Langchain. So similarly, here also, instead of using directly with similarity search or with similarity search with score, you can use a retriever so that when you are building chains, it will be helpful to you, because your retriever needs invoke function, your prompt need invoke function, right? Your LLM needs invoke function, all needs invoke function, so that one input will go to another, one output will go to input for the next step, that output will go to input for the next step. We have already discussed all these things in string output parser. For the same reason, that is the one reason. And second reason, if you use a similarity search, you will get only a basic similarity search along with your vector store. But if you use retriever along with your similarity search, you have multiple search operations. You have Kohare re-ranker. So there are so many, search algorithms are implemented inside retrievers. So you can also use those advanced RAG techniques if you use a retriever instead of direct function from your database. So that in a moment I'll show you what other you know uh, s- what other kind of searches you can do, that we will see going further. So let me take one retriever first. So, and your retriever needs couple of things. So declare a retriever variable, and you have to take your vector store reference, and then you have to use as underscore retrieve function. Inside search arguments you have to pass, and same there also we are passing k value 2 or 3. Here also you have to pass the same thing. Let me take 3, right? So now your retriever is ready. Once your retriever is ready, then you can invoke this retriever by passing any unstructured query, right? So let me quickly ask one query. Retriever dot invoke retriever dot invoke. So this time also I will ask the same question. Let me copy the question we already have, right? Paste it and then execute. So now you can see that it also given three documents: document 1, document 2, and then document 3. So for if you want to see in a better way, let me store it into results variable. Let me store it into results variable, and then I am going to write one for loop, and I will display only documents. All right. So I have taken one for loop. I'm looping through results, and then I'm printing page content, and then I'm giving uh, one line break. Right. Execute it. So now you can see that you got three outputs. So this is how your retriever works. So I hope retrievers are clear. So if it is clear, then I will take you to a Langchain document, and I will show you what other kind of retrievers are available inside Langchain, right? Retrievers in Langchain. So you select official document. You can see this logo is official documentation of for a Langchain. All right. So you can see Wikipedia. We have seen uh, you have a Azure AI search retriever. You have Elastic search retriever, and then with external you have Wikipedia retriever. We have already exposed this. You have Travely search API retriever. In case if you want to give any search functionality to your application, you can use this. Just click over here and then go to that particular link. Then you can see the steps how to implement these things. So in this case, you need Tavily API key. You have to go to Tavily website, create a API key, and then install these libraries, declare a retriever, and then pass your query. Retriever will give you a documents as an output. So whatever retriever you use, process will be similar. Some retrievers might require API keys, some might not require API keys. That is the only difference, right? So I hope retrievers are clear. Let us quickly go to our syllabus. So we have done text splitters, vector stores, we have done retrievers, and we are going to discuss about a RAG and simple RAG application. So let me quickly tell you what is RAG, why we need RAG, and then what is architecture of the RAG. Then we will see a demo how to implement RAG and then close this session. So I hope everyone clear. All right. So now, uh, if you see any LLM, so we have discussed in session one. From session one, what we are doing, we are asking a query. We are asking a query to the LLM, and LLM will give you output. So this is how all traditional LLMs are working, right? We have given text as an input, it is processing, and it is giving text as an output. So what will happen in general? These LLMs are trained with a massive data. These LLMs are trained with the massive data which is available over the internet, right? So what will happen if any data not available over the internet, and if you start asking question to your LLM, and your LLM may not give the answer because it doesn't know what you are talking about. So for simplification, let me say you are working in a company called XYZ. You are working in a company called XYZ. So every organization will have some policies, right? Let's say you have one leave policy or HR policy in your organization. Since this is, a private data, particular belongs to the XYZ may not keep it publicly, right? Since it is not available publicly, your LLM is not trained with that particular data. So what will happen if you or any of XYZ company employee goes to LLM and ask a question, how many leaves I can avail in uh, in a month. So obviously LLM will fail to answer that question because it doesn't aware about your organization data. So this is the problem number one. So LLMs will not aware of your private data. The second problem is every LLM is released at particular date. Let's say Google, right? Gemini 3 has been released, I think, a couple of days ago or 3 days ago. So whatever happened after 3 days, that Gemini 3 model will not be having aware of whatever events are happening after these 3 days. So it has a knowledge cutoff. Knowledge cutoff. What is knowledge cutoff? Uh, let's say you are training your LLM with the data, and you released your model at particular date. Uh, for simplification, let's say in January 2025, your LLM has been published. Sorry, your LLM, your training is done, and your LLM has been released in January, right? So after that, you haven't trained your LLM with the new data, correct? So what will happen if I start asking questions, whatever events happened after January, your LLM might not be aware because your LLM has knowledge cut off to particular date. So this is the second problem all these LLMs will be facing. And third problem, hallucination. So when LLM doesn't know the answer, it will not accept that I don't know the answer. What it will try, instead of telling I don't know answer, it will it will mock up some answer. It will create some answer which is obviously a false answer it will create, and it will give you as an output. So this is called hallucination. Means LLM doesn't have any knowledge about that, still it will try to give some answer to you. So these are the major problems LLMs are facing. So they are not aware of private data, they will be having a knowledge cutoff, so that they don't have any idea about latest events. And third problem is hallucination. Even though it doesn't have any idea about particular topic, still it will try to give you some answer, correct? So these are the problems. So for these problems, if you want to solve, you need to you know you they have introduced a technique called fine tuning. They have introduced a technique called fine tuning. You can see over here, fine tuning. So what is fine tuning? uh, let me say this fine tuning is a technique. What will happen? Whatever the model has been released, that model it will pick it up and it will give additional, additional data, uh, be it organizational data or be it about latest events or anything else. You will give additional data to the LLM so that LLMs will be aware of this private data now. Correct. For that, what you need, you have to take already trained model and then you have to train with your own data. So this technique is called fine tuning. You are taking LLM, raw LLM, and you are giving your new data in a training. So generally training will happen in multiple things. You will give a supervised training, you will give unsupervised training. So what is the supervised, unsupervised, RLHF and all? We no need to be worry as of now. But simply I will take in supervised training, they will give labeled data for the model so that some structured data they will give to the model so that model will train with particular data. In unsupervised case, they will give a raw data as a training input. So that is called unsupervised data. One more is RLHF, also called reinforcement learning with human feedback, where you will ask the question and you will keep on giving the feedback so that LLM will learn this is good answer, this is bad answer. I no need to repeat this. So this is a, over time your LLMs becomes perfect. So in simple, fine tuning means fine tuning in simple I'll say you already let's say you got the job in a MNC company, right? So on generative AI, you already trained about generative AI, either in your college or in any third party institutes like Euron or somewhere else, right? You might be trained about generative AI. Still, once you enter into your organization also give you some training. So whatever training you got, whatever training you got before entering into the organization, that training is called pre-training. Once you enter into organization, they will also give some kind of training. That training you can call it as a fine tuning. It means that taking a raw model and making it specialized into some particular thing. So this is a simple detailed about fine tuning. But fine tuning has some limitations. Fine tuning has some limitations. The first limitation is going to be it requires a lot of computational power, which means let's say uh, your model, let's say you have picked up one model which is 176 billion parameters, right? Nowadays even trillion parameters are coming into the market. So 176 billion parameter if you take and if you want to retrain with your data, you need a lot of GPUs, and GPU cost will be obviously it is high. So for that, what you need to spend more money for doing fine tuning. Second one, this is not an easy job. You need some technical expertise. You need some technical expertise. And third problem is you need to invest a lot of time to prepare these data sets. Let's say if you are selected a supervised training, you need to prepare labeled data. Obviously, you need to prepare labeled data, and that labeled data will be prepared by someone, and someone has to review that data. So you have to invest a lot of time uh, to prepare this data. So all these are major problems in fine tuning. And uh, let's say you have already fine tuned one model and your data is changing again tomorrow. Again you have to do fine tuning. Again day after tomorrow if your data is changing, again you need to do fine tuning. So it is a continuous process. If you are keep on doing, you will start burning your money, right? So to avoid these things, there is a concept came into the picture called RAG. What is RAG? A simple abbreviation is retrieval augmented generation. Retrieval augmented generation. So as of now, let me take you to the structure of RAG and then I'll come back to here so that you will get the better idea. All right, I hope it is visible to everyone. All right. So what is the structure of RAG? See, If you see this document, you will understand a clear picture of RAG. What you have some documents, because let's say you take the organizational case. In organizational case, we will be having leave policies, we will be having medical policies, we will be having code basis, we will be having project requirement documents, we will be having HR related policies. So we'll be having several kind of source documents, correct? All source documents using document loaders, you have to load using document loaders. After loading this data, you have to use some chunking strategy, be it a character split or recursive character split or a uh, semantic splitting. Whatever the chunking strategy you use, you have to use some chunking strategy, and then making it into chunks. Once your chunks are happens, you have to pass those chunks to one embedding model. This embedding model is responsible for converting your chunk into a numerical representation of your chunk, correct? We have seen already in this example. So we are passing your text to your embedding, and your embedding is converting that text to a vector representation. Once you got the vectors, those vectors you are storing inside your vector DB. So this is step one inside your rack. What we have seen here, we have seen document loaders, we have seen text splitters, and we have seen embedding models, and then we have seen vector stores. Now your vector store is ready. Let's say now user comes to your system and asks some question. What will happen? Your question will go to same embedding model, whatever the embedding model you have used while you know converting your chunks to embeddings. Same embedding model you will use. You will also convert your query to the equivalent vector. Now once you got the vector, what will happen? You have to use a retriever. Retriever will query your vector db, and your vector db will give some output, correct? Some output. Once that output got, what you will do, you will pass your prompt along with whatever data you got from the vector db. You will pass your question, and you will pass response from your vector db uh, to the your llm, and your llm will give the response. So if you see this, we have five components in this. One is document loader, one more is text splitters, one is embedding models, and one more is vector db. Once this is done, and we have a retriever. Once this is retriever done, again we have one uh, llm model to generate the final response. So this is how a rag works, right? Now let us go here, and you can see, since we are retrieving data from our vector store, so this part retrieval part is going retrieving data is going to call as a retrieval. Once you got the data, you are constructing a prompt with user query and as well as some context. What this context you are getting from your vector store. That's it, right? Your retriever will get some documents as an output. That output you are passing as a context to the llm, and llm will take care of the generation. So this process, what you are injecting the new prompt plus user query plus context, it is called as a augmentation. Then llm is generating the response. That since it is generating, it is called generation. So in short, it is called as a rag, a retrieval augmented generation. With rag, what problems we are solving? We are solving private data problem, because obviously whatever the documents you have in your organization, all you are storing into your vector db, and your vector db will give the context to the llm. Now llm has clear idea what is the answer for this query. Then latest events, uh, it is as simple as that. Whenever you want to insert some data, use insert method and you will insert new events information inside your vector db. Third is hallucination. In your prompt you can mention something like uh, answer this question using only this context. That context will be coming from your vector db, right? So if this context is not related to user query, then you can instruct your llm that if you don't find any context inside my prompt, you simply say that you don't know the answer, so that you are also solving hallucination problem. So I hope it is clear what problems we are why we need rag, and what problems we are going to solve using rag, and what is the architecture of rag, right? So now what we will do, we will see a demo how to implement a rag application, and then we will close this session. All right, so let me go to my Visual Studio Code. So what I'll do, since already it is 9 o'clock, I will quickly take the file and explain you the code instead of writing the code. Otherwise, it will eat up, you know, so much time. So for that, prerequisite is I'm using Pinecone in this. So what I'll do, you have to go to Pinecone. Just search for Pinecone. You will find that a Pinecone website over here. Just click on it. Pinecone.io it is, right? What is Pinecone? We have already discussed, right? It is a vector store which is hosted in a cloud, like how your EC2 will be with EC2 with AWS. Your vector store will be with Pinecone. Now quickly click on sign up. If you don't have account, you can simply click on sign up. So it will ask you to sign up using any email. You can take any email and you can sign up. Since I already have account in Pinecone, what I'll do, I'll simply log in. Let me click on login. Just a minute, guys. Uh, take your Google. I logged in with Google. I'll take one of my email. You can also do the same thing for sign up as well, right? All right. So once it is done, you will land up with some page. So initially, if you don't have any database, it will ask you to create a database. Once you create a database, come to the index part. You can simply click on create index. Once you come to create index, it will ask you index name. So think like this. Index is nothing but your table, right? Let me give me one name. So it will only accept low letters and no numbers. So let me do that. Let me give test. Once you give the index name, it will ask you the configuration. So what kind of embedding model you are going to use. So we already know for this purpose we are going to use text embedding 3 small. So I'm going to select text embedding 3 small. If you are using different models, multilingual EFI laws, there are n number of models are available. You can also manually configure as well, right? So let me quickly select this and go to check on custom settings. So what will happen by default, your vector dimensions in Pinecone, it will be fightful, but in your OpenAI embeddings, especially that embedding model we are text 3 small we are selecting, it will give you 1536 dimension vector. So for that, what you need to do, you have to select 1536 dimension. That's it. Once this is done, you have to select which cloud provider. It is up to you if you want to select AWS or Google Cloud or Azure. Three options they are giving. And guys, this is completely free, so you don't need to worry. You don't need to pay anything. So you can select AWS. Once you select that, it will ask you the reason. Let it be default reason, and then click on create index. That's it. So successfully, index will be created inside your Pinecone. Right. Now, if you want to connect, what you have to do, just click on connect. They have given some things you have to install. Pinecone first. Once you install Pinecone, you have to take a Pinecone object, and then you have to take one index reference and all. So let's see, when we are writing the code, we will see all these things. So after once this is done, make sure your dimensions are 1536, because the model we are using, it will give 1536 dimensions. In the session 1, I have showed you what is the length of that particular vector, right? It was 1536. I think if you use a Google model, we got some 3068 something. In that case, you have to use 3068. It is simple. You take your any embedding model, you hit one call, it will give you the output. Just check the length of that output. If length of the output is 1536, add 1536. If it is different number, give that number here. That's it. So once this is done, you required API keys. So just go to API keys section, and then you can see some APIs are already declared over here. If you want to create a new API key, you simply select API key, so that you give the API key name. Any API key name you can give. Let me give lang test something. Select all permissions and then create key. Now your API key has been generated successfully. Just a moment. Please note down, we need this key. You can simply copy it, right? Once it is done, uh, just close it. Before closing, make sure you have copied your key, otherwise it will not give you the option to copy second time, right? What you can do, you can simply delete and create new API key instead, in case you didn't copy it. Okay, all right. So once this is done, I'll go to my Visual Studio Code and I will add my file over here. So this is going to be my code. So let me quickly walk you through the code. Before I walk you through the code, you need to install a couple of packages. One is, we have seen just now, pip install pinecone, right? Just install pinecone, hit enter. Let it install that package. So meanwhile, you need one more package, which is pip install langchain underscore pinecone. So make sure you have activated your environment, otherwise it will install globally, right? Still it is installing. So meanwhile, yeah, it is done, guys. So once this is done, you need one more package called pip install langchain underscore pinecone. So if you see earlier, all our vector stores available inside langchain underscore vector store. Even pinecone is also available, but their latest package they have installed separately, like OpenAI, how we install, right? Pip install Langchain OpenAI, like that. They have also released pip install Langchain underscore pinecone package. So if you use inside this vector store, if you use this, will also work from langchain.vector store import pinecone, which will also work, but it has, older versions. You may face some issues. That's why I'm going to install new version of pinecone. Right. Once this is done, could not find version. Give me a moment, guys. Some spelling mistake. Could not find version that satisfies the requirement. pip install langchain underscore pinecone. I don't know. Let me ask ChatGPT. Give me a moment. Okay. It is telling Langchain pinecone, not underscore. Okay. Let me copy it and then paste it. So let it install. Meanwhile, I'll explain the code. Right. So first things first, what we need? We need PyPDF loader from Langchain community. We need recursive character text splitter. We need OpenAI embeddings. We need Pinecone client to connect to Pinecone vector store, which is available over cloud. And then we need one prompt template. We need one chat OpenAI LLM, and as well as we need one while loop for asking a question after a question. Right. Till now we are hard coding questions, but this time what we will do, we will ask a question one after one more question. Right. All right. So now what will happen? Let us import these things first. So from Pinecone, from Pinecone package we have installed just now. We are importing Pinecone. From document loaders, we are importing PyPDF loader. From text splitter, we are importing recursive character text splitter. From Langchain OpenAI, we are importing OpenAI embeddings. Right. And also from Langchain underscore Pinecone, we are importing Pinecone vector store, and we are importing chart OpenAI and prompt template. Basically, whatever we have mentioned over here, all imports we have done over here. Right. After that, what we have done, we have loaded our environment file. Our environment file should contain a couple of keys. One is OpenAI API key, and one more is Pinecone API key. Right. So let me quickly go to my env file. I have OpenAI API key, but I don't have any Pinecone API key. Let me do one thing. Let me quickly add that key. Just a moment, guys. I have copied my thing somewhere. Allow me a moment, or I have to create a new key. Let me do one thing. Let me create a new key, and then I will add it over here. So what I'll do, I'll go to Pinecone API key section. I'll add new key, create a key. Right. Once you create, you can see your key, and then you can copy over here. So let me come here and then add it in caps, Pinecone underscore API. So let me change it if it is a wrong key name. Let me go here and see Pinecone underscore API underscore key. Right. So I have to add this exact key, otherwise it will give the error. Now I have my OpenAI API key, and I have my Pinecone API key. So both requirements I have given. Right. After that, what we have given? We have given Pinecone index name. So just now we have seen how to create Pinecone index. You can simply go to inside databases. I have 5 indexes. Inside my 5 indexes, you can see these are my index names. If you want, you can delete. If you want create, you can create new one. So one already I have created one, which is called Langchain tutorial. So I'm using the same index name. Once that is done, what I have taken, I am taking a PDF path to load my file. So this is the file I'm going to load. We have already seen couple of times the system architecture design document file. The same file I'm going to load into my vector store, and I'll start asking the questions so that it will try to fetch answers from this document and it will give it to me. Right. So up to here it is clear, I hope. Then I'm checking OpenAI API keys exist or not. from my environment it is loaded successfully or not. If not loaded, I am raising an error, set OpenAI key environment variable. Similarly, I am checking FineCone API key as well. If FineCone API key is not exist, then it is going to throw an error. So once this is done, my first step, if you see the RAG architecture, what is the first step? You need to load the documents. Once load the documents, chunk it, pass it to embedding model, and then insert into vector DB. So this is the step we are going to start here. First, what we are doing, we are loading PDF file. So for PDF load, what we have taken, PyPDF loader we have taken, and then we are passing this PDF path. Correct. So this is the path I am going to pass it, file path. Then after that, I am loading the document. Once this is loaded, it will store in raw docs, and simply I am checking length of the raw docs. Right. So since it has 6 pages, it will be length is going to be 6. Now, document loader is done. Once document loader is done, we need to do split. For that, what I have taken, I have taken a recursive character text splitters. So chunk size I have given 800 and chunk overlap I have given 150. These are configurable parameters. If you want, you can change 1200 or according to you. You can give it, right? So I'm taking the splitter and then passing my raw docs to the splitter so that my splitter will create a multiple chunks over my documents. And I'm also printing that length as well. Correct. Once this is done, we are initializing a Pinecone client. We are connecting to a Pinecone using our Pinecone API key. So we are this is the create index code. Since I already created index, I feel it doesn't make any sense to add this code. So that's why I have commented this. Once this is done, I am declaring one embedding model, which is from OpenAI embeddings. Then I am creating a vector store, and that I am passing one embedding model and passing documents, and index name I am passing my Pinecone index name, which I have declared over here. Right. All right. So once this is done, I'm taking one retriever. We have seen this as well. Vector store dot as retriever. I'm getting top 4 results, nearby 4 records. In case if you want 3 or 2, you can also add it 3 or 2. It is up to you. After that, I have declared one prompt template. I have declared one prompt template. What I am telling you are a helpful assistant. Use the context to answer the question. If the answer is not in the context, say I don't know, not inside context. I am passing context, whatever the context I am getting from my vector DB, that context I will pass here, and whatever the question user is asking, that question I will pass it over here. Then I am also telling answer in simple words. If you want to give any extra instructions, you can also provide. So why I have given this particular instruction, if the answer is not in the context, say I don't know, not in context, because I want to avoid hallucination of the model, right? All right. So once this is done, I'm taking a prompt using prompt template. In the template, I have passed all this prompt template, and this template is having 2 input variables, correct? One is context, and another one is question. Uh, Question will come from the user, context will come from the retriever, right? All right. So once this prompt is done, I have also declared one LLM so that this will go to LLM and LLM will give the final response. Now I have declared one function answer query. In that I am invoking the retriever. Retriever will give me the context. Final prompt I am invoking by passing context as well as user query. Once final prompt is ready and I am passing to my LLM will give the response. That response I am returning from this function. All right. So if you come to my main function, I have given one while loop. So every time you ask some question, it will append. It is asking you, and every time AI replies, it will append assistant. Right. So in case instead of question, if you type exit or quit or buy, it will say goodbye because you don't want to chat anymore. Otherwise, it will keep on asking you the question. Correct. So this is the simple code for the simple RAG implementation. Now, once this is done, let me run this file. I have installed the required packages. Hopefully I don't get any error. Let me run and see Python rag. Inside rag, it is rag demo.py. So let me run it. These files will be available. Okay. So I'm getting some error from PyPDF. Uh, File path is not valid. Okay. Let me do one thing, guys. I have given absolute file path. So since both are in the same file, let me do it this way. I'll give only a relative file path. Then let me run again. Let me clear it. It is so messy. Right. So let me run it. Hopefully this time I shouldn't get any error. Again, same error. File path is not valid. Is that a spelling mistake or I'll do one thing. I'll copy the file path, copy path, and then paste it. So just use double slash, otherwise you may get the error. Okay, save it and then run it. I may get other error this time. Hopefully, yeah, our file is loaded. You can see that 6 pages has been loaded and 13 chunks has been created. Now it will try to insert these embeddings into our Pinecone vector store. All right. So Pinecone upsert is complete, and as well as RAG system is ready. Ask questions. So basically our system is ready. If you want to see, you can go to our Pinecone. So I think this is the table. This is the index name I have used. So just click over there. Now let me check what is the name I have used. I have used Langchain tutorial. Is this the same one? No, this is not the one. This is Lang tutorial. Yeah, this is the index I have used. So now you can see that there is a record count of 52 over here. So earlier also I have inserted some record, so that's why it is showing record count as a 52. So in case if you want to see only those records, let me do one thing. Let me quickly delete and then create a new index so that it will not be having any confusion. Let me delete it. So it has been successfully deleted. Now you can see that it is not over there. Let me create a new index with the same name, and this time I'm going to select text embedding 3 small, go to custom settings, give dimension as 1536 because our embedding model gives 1536 dimension vector, right? Rest everything keep as it is and then create index. So it will create the index, right? So our index is up and ready. Now record count is 0. All right. So what I'll do now, I'll go to my program. I will kill it and then I will try to rerun it. CLS and then run it again. All right. So it will try to insert vectors in my index. So hopefully this time I should see some number over here. All right, you can see that record count is 13. Also, you can cross verify our chunks are 13, all our chunks are successfully inserted in our index. Now I am good to go with the questions, right? So first I want to open the document and then let me copy the path. Let me show you what content it has. Okay, so this document describes the system designed for large scale energy meter platform that connects up to 1 lakh field devices. So let me ask uh, how many devices this document is considering. Some question I will ask. uh, how many expected devices this architecture has been designed. Let's see what will be the output. All right, so you can see the content. The architecture has been designed to handle up to 1 lakh devices, right? We have also seen the same thing from our PDF document. So now let me ask one more question, which is related to document. What is there? Uh, is this architecture using DynamoDB or not? I will ask. It should obviously say yes. Is this design using DynamoDB? This is my question. You can ask any question basically. So, all right. So you can see the content. Yes, the design is using DynamoDB to store important information about each device and to manage command status. So since I'm printing all the response, that is why this messy response is there. So instead, you can only print content so that you can see the content. Let us see quickly that as well. Let me exit it and then mm, so I'm generating answer, right? Instead of answer I will do answer dot content. So let me try to execute it. Yeah, so let me ask the question this time. I have copied already. All right, so assistant has replied yes, the design is using DynamoDB. What are the expected devices? So obviously we know the answer, it should be 1 lakh. So assistant also give no. I think I should change my question. Um, how many devices will this design supports? So something like that. I'll some meaningful question I will ask because last time. All right. So you got the answer. The design supports up to 1 lakh devices. Now let me answer. Let me ask the question. Who is our prime minister? So obviously this information we don't have in our vector store. So our context should be empty to the LLM uh, or which is not related because we don't have any details about our prime minister, right? So it has to give that I don't know the answer. So let me ask the question. Who is our prime minister of India? See, assistant has given the reply saying that I don't know, not in the context. Why? Because in prompt we have given clear instruction. If related answer is not in the context, you just say I don't know instead of giving from your own knowledge base or some hallucination answer. All right, guys. So we have successfully built a simple RAG demo, and we have seen how it works as well. So let me quickly go to our session agenda today. So I think we have successfully finished basic text splitters, vector stores, retrievers, RAG and sample RAG application. So that's it for the today, guys. So these codes and this material will be available in description after some time. You go, please download it. If you haven't practiced till now, start doing it. Next week we will come up with another interesting topics in Langchain. So with this, the live is going to end.